Logarithms and exponents. This is your base. When you rewrite it as an exponent, you leave that as your base. So the 5 stays down below, and you just change these two. So 2 becomes your exponent, 25 becomes your answer. This one you just work backwards. So you have log, whatever your base is your base down here. And then you just switch these two. So you have 1/25 equals -2. For 64, you're multiplying two things. When you multiply, that means you're adding two separate logs with this same base. So you have log base 7 of 7 plus log base 7 of x. Each one of these becomes its own thing, and because you're multiplying, you add them together. 65 says to expand it as much as possible. When you're multiplying, you add, but here we're dividing, so we're going to subtract the logs. I have log base b xy squared minus log base b of z to the 5th, and they're subtracted because they're being divided. Now I can separate these out because I have two things being multiplied together. So when they multiply, they're going to be added. So I have two logs. I have log base b of x, and I have log base b of y squared. This one stays the same, so I only have one thing. I'm not multiplying anything else out. Now the only other thing I need to get rid of, or change or expand, is my exponents. Your exponents come in front of the log. So your final answer for this one would be log base b of x plus 2 log base b of y minus 5 log base b of z. For 66, you're subtracting, so that means that you're dividing. When you have a number out front, that means that's your exponent. So if I rewrite these as exponents, I'd have this. And when I'm subtracting two logs, that means I'm going to divide them. So I have this, which when you simplify, this ends up becoming a 4th root. So you have that as your final answer. Now we're working backwards. So again, this is my base. I have log base 4, and I'm going to trade these two. 64 equals 1 plus 2x. Now I need to use the formula that I can type into my calculator because I can't type it in just like this. Remember, your base goes on the bottom. So we have log 4 on the bottom, and whatever your number is here is what goes on top. So log 64. When you type that in your calculator, log 64 over log 4 gives you 3. And then just solve for x. So minus 1, 2 equals 2x. Divide both of those by 2, x equals 1. Same thing for 68. Let's rewrite it as a log. So log base 32 of 8 equals x. So I have log of 8 on top and log 32 on bottom because that's my base, and that equals x. When you type that in your calculator, log 8 over log 32, you end up with 3/5. Log base 2 of 32 equals 1 plus 2x. We have log 32 on top and log 2 on bottom. When you type that in the calculator, you should get 5 over here. Log 32 over log 2 is 5. Then solve for x, so we're going to subtract 1. 4 equals 2x. X equals 2. Log base 18. Remember to trade these. On top we'll have log 1 over log 18 equals x. And that equals 0. And for the last one, if you rewrite this as an exponent, you would have 5 to the third power equals x minus 1. Remember, you just switch these two. 5 cubed is 125. So then just solve for x. Oops, 126.